Today I'm going to show you how to make this lightning bolt effect in Unreal Engine 4.0. Let's get started. Okay, to start off, we're going to need to make a new material. So let's create a new material. Let's call it lightning bolt. That'll do. Okay, let's set our preview to real time. That's good. Make it a plane. We'll also need to set the blend mode to additive. Set the shading model to unlit. Make it two-sided, so our lightning bolt will have two sides. I mean, does anybody really want a one-sided lightning bolt? Okay. Now that we've got that started, you'll see here in our outputs we have emissive color, opacity, world position offset, and refraction. We're only going to care about opacity and emissive color. So let's get started. First off, let's create a particle color node. This will be where we get our color from when we put it into the particle system. Okay, let's add a multiply. Take the particle color, plug it in there, and let's plug that into the emissive color. Now we just got this white square. It's a start, but we don't want a square. That's not a lightning bolt. Okay. Up next, we're going to need to create a generated band. This is a material function inside of Unreal Engine 4, which combines a whole bunch of other things together to give us this really simple way to make a band. Okay. Let's plug that into here. And now, as you can see, we have a band. But it's going horizontally and it's pretty thick. Oh yeah. Also, we're going to plug it into the opacity. Now we have a transparent band. Now that we've got that, we need to make some changes. First, let's add a static boolean or static bool. Set that to true. That will give us a vertical band. Now we're getting somewhere. Then we need to add some width to it. So let's create a constant. Plug it in. And set it to 0.0075. Now we've got a nice little band. Also, let's duplicate that constant, plug it into our sharpness, and let's set the sharpness to 0.75. There we go. There's a thickish, not too thick, not too thin band. Now we want to get some random motion into things. I mean, we don't want it to just sit there. and always be precisely in the center. So to get that started, we're going to add a time input. And then we're going to clamp it, set its minimum default value to 0.1. Also, we're going to change the clamp mode to minimum. This will make sure that we've always got that it's never 0. We don't ever want to get 0, because that'll cause some undesirable results in the lightning bolt effect. And then we're going to add a sign. We're going to take that time and the clamp into the sign, set it to something like, for this example, 6, but you can mess around with it and do whatever you want. Then we'll take our sign, put it through a cosine, which we will set to 10. Then we'll get another sign. This one, maybe set it to 3. What we're doing here with this time and the sign of the cosines and filtering them through each other, we're setting up a randomness that'll jitter around the line to give us a more random effect. Now that we've created this time-based wave monster, we're going to plug that into the offset, and we should start seeing our first signs of animation on this thing. And there you go. It's jittering back and forth. Alright. Let's get on to the part that's really going to make this thing just sing lightning bolts. Alright. First off, we're going to need to get our noise clouds distortion texture. Here we are. I created this in Photoshop by layering a whole bunch of clouds filters a couple of times, taking the white value of that and then copying that into the green and red channels. Why green and red channels? Because we're going to be affecting the UV coordinates. This will force distortion onto the generated band that we've made. Alright. Now with the distortion selected, let's pull up our lightning bolt material again, and pressing the T key, we'll bring in a couple texture samplers. We will use one sampler per color. To get things started, We're going to start with the green channel. Drag off the node and add a panner. And we'll set the X speed to 0.5 and the Y speed to 0.5. Then we'll just add a make float 3. Now we'll go in, take our green channel, plug that into our X. X is the channel that we want to affect. The Y channel affects up and down motion. The Y channel is up and down, and the X is back and forth. We only want to affect the X, so we'll plug the green channel into the X, then the Y, then we'll take our blue channel, which is set to black or 0, and plug those into X and Y. And then we'll have a float 3. Then, to make this usable for our UV coordinates, we'll add a component mask. Make sure it's set to mask out to leave only the R and the red and green channels. Plug that in here. And while we're at it, let's get started on the second copy. Let's just take this make float 3, duplicate those, pull them down here. And for this one, we'll plug the red channel into the X, and again the blue channel into the Y and the Z. And for this texture sample, take another panner, plug it into the texture coordinates. For this one, we'll set it to 1 and negative 0.5. Additionally, just to set things off on a little bit of a different position, I'm going to take another time node, then I'm going to add, I'm just going to add 1 to it, and plug that into the time for this panner. That's looking pretty good. Alright. Up next, let's take alright, let's just add these two together and plug them into the input coordinates and see what happens. I'm expecting a disaster. While that is a cool effect, that's not what we were hoping for. So let's disconnect that for now. And to get things started, let's add a texture coordinate node. As you can see, it's just a couple of gradients going from black to green, and black to red, and yellow down here. Basically 0 to 1 in both green and red. To get things started here, or Let's give you another example. Let's take another add, plug it into here, and plug this into here. Now we've got something more usable. It's getting better, but we need to tone things down a little bit more. Okay. Let's delete that. With this texture coordinate we just made, I'm going to take another component mask. And for this one, I'm going to mask out just the red channel. What this is going to do is make us a lovely gradient. Going from a nice horizontal gradient, because that's what we want to affect. And to reverse the gradient, we're going to need to make, we take two of these gradients. One will be reversed. We're going to add a 1 minus node. As you can see, it has flipped the gradient. Then I'll add a power. This will allow us to boost up the intensity. We'll set this to 2.5. Plug our mask into the base. Copy it again. Duplicate it. Put it down here. Plug it into the other base. Now I've got a couple gradients. And then we will add a multiply node. I press the M key to get a multiply. Plug that in here, and plug the other one into B. And now we've got a nice kind of a band, I guess. But this one we're using as a mask for our UV coordinates. Never mind that. Okay. Next up, let's duplicate this multiply, plug this into here, and for our constant B, we'll set that to 2. That'll boost the intensity of this multiply. And we will duplicate it one more time while we're making our mask to keep things simple. And for this one, we'll set it to 0.8 to tone down the intensity of things later on. We're just setting up masks right now for the future. And once again, we need to get another copy of this. We need to get another copy of this texture chain. Duplicate that. Pull this down here for a little bit more variation. Only this time, we're going to be changing up how we get our X value. This time we're going to take an add node, and we're going to add the X, we're going to add the red and the green together, and then put that into our X output. And another component mask. Okay, there we go. Then, now it's time to put all these pieces together and show you how we get that final result. Oh, wait a second. Down here on the third mask we're going to change that add to the time and change the add to 0.5. And for the panner, we'll set the X speed to -1/4 or 0.25, and we'll set the Y speed to 0.6. You can change this up however you want. It's useful this way. Tweak things to how you see fit, and hopefully that'll work good for you. I mean, you don't have to worry about specifics. This is just what I used to produce my result. Okay, to combine all these together, we're going to use a linear interpolate node, also known as a lerp. Now, I'm going to make a few of these. 3 lerps. There we go. For this first lerp, let's take, well, first let's delete this add that we made. For our first lerp, for the A input, we're going to add a texture coordinates. Texture coordinate. And for the, oh wait a second, never mind. We're not going to use the lerp for this one. Break the link. We're going to plug our mask into the B channel. By default, a lerp's constant A is black. That gives us a red texture. Now we're going to go in here, take this first multiply we made, and we're going to plug that into the alpha. As you can see, that really toned down the red effect, and it'll also fade off on the edges, because we don't want any funny things happening on the edge of the coordinates. So for that lerp, we'll take this, our second lerp here, we're going to plug in our second mask texture, and we'll plug this multiply into it. And then we'll take our third one down here, and again plug it into the B of this lerp, of this linear interpolate, and our third gradient mask into its alpha. So now we've got that. It's time to add everything together. Okay. Let's take our texture coordinate, add an add node, as you can see, there we go. We've got a texture coordinate going on. Doesn't look like much right now, but you'll see in a bit. Let's duplicate this add, plug its result into this new one, and then add our second animated mask, and do it one more time, plugging that into the A slot, and this final one into the B slot. And now let's plug that into our input coordinates. And we'll move this graph over to keep things nice and tidy. And there you go. We have our basic lightning bolt band material. Awesome. Now let's save our texture, make sure it compiles. Good. Now, I'm going to show you how to do the particle. Let's pull up our particle generator. Okay, let's make a new particle here. Let's make a new particle system. We'll call this lightning bolts. Awesome. Well, not lightning bolts, I mean bots. Lightning bolts. Here is Cascade. We've got a lot of things going on. This is the default Cascade window, and this is not what we want to see, at least at first. Alright, let's start editing this thing to get more what we want. In the required node, let's go to the material, and let's find where our new lightning bolts material is. Lightning bolt. There we go. And now we have our lightning bolt in here. And that's, well, that's cool and all. That's not exactly a lightning bolt. But there could be more than one use for this material that we've made. But this time, our goal is lightning bolts. It comes with the initial settings. I mean the required settings. Nothing much is to care about here. Okay. Up next, let's edit the spawn. Let's set the rate from 20 down to a mere 2. That's better. Check our rate scale. We're going to keep that at 1. We want a constant float, distribution float constant. That means every so often it will spawn, every 2 seconds. No, it'll spawn 2 particles every so often. Up next, let's take a look at the lifetime. Since it's a lightning bolt, the lifetime should be pretty quick. So we'll set a minimum to 0.2 and our max to 0.4. Now the fun part. Initial size. Alright. For initial size, we'll go for distribution network. Distribution vector uniform. For the max, we'll set this to like 10,000. We're talking in centimeters here, so even this may be a little small, perhaps. Set the Y to 500, the Z to 500, for the min, for the X let's do 9,000, for the Y 500, and for the Z again 500. Now that we've got our nice big lightning bolt, it's time to change the velocity. Because obviously we don't want this thing to be flying away too much. Let's set the max to 0x, 0y, and -1z. And for the mins, again 0 for the x, 0 for the y, and -0.5 for the min. We always want a lightning bolt to be only coming down if it's going to be doing any movement. We're actually going to remove this, delete the color over Leif module, and instead we're going to add a different color module. This one will be initial color. We don't care about our start alpha. We'll use a distribution vector uniform, set our max to something like that. It's a little bit small right now, so let's boost up our blue channels to say 10, the green to about 5, and the red to about 4. As you can see, now we're starting to get some of that beautiful bloom as it's pushing beyond the 0 to 1 range. And we're pushing up that intensity. For the min, I went with basically the opposite. Different, like a nice warm color. Now we've got randomly colored lightning bolts. Of course, these colors, you can edit them as you see fit. Set them to a fixed color, set them to a random color. Your choice. But for my example, I want to have randomly colored lightning bolts because that's cool. Now to finish things off, let's add another little node. It's called an initial location node. There's a distribution vector uniform. For the x, max we'll start with 5,000. For the y, another 5,000. And for z, we'll keep that at 0 because we don't want this thing, at least not at this time, we don't want it flying up and down in space. We just want it back and forth, forward and back in space. For the max, we'll set it to -5,000 and -5,000. Now we've got now we have a 10,000 centimeter space that this thing is gonna randomly spawn in. And that's about it for this particle emitter. Then save your particle emitter and use it. This is a super cheap, super efficient way to get quick lightning bolt. And you could use the material created for this effect in many different ways. In this example, we just used it to make a lightning bolt. It could also be used for arcing electricity or any other thing you want to use it for. So, I hope you enjoyed this quick tutorial, and thanks for watching. Click like and subscribe if you liked it, or dislike if you disliked it, and leave a comment if you have any comments or whatever else. Alright, I'll see you later.